All right, class, we have learned 3 different ways of figuring out whether a function is linear or not, and those are listed for you up here on the board. First is, if you graph it, you better come up with a line, or something that is at least approximately linear. Number 2, we have to have an equation that's of the form y equals mx plus b. And 3, we need to find a consistent rate of change when looking at values in a table. One thing that happens, though, when we're looking at example number 3 is that sometimes we're given tables where finding that consistent rate of change is not too easy. I'm looking at this table of values, and notice my x values go up by 3, up by 2, up by 5, up by 2. My y values are up by 12, and a variety of things. At first glance, this doesn't look linear at all. But we need to take into consideration that our x values are not going up by 1. In order to tell if something's linear or not, it's very, very handy to have those x values going up by 1. So I would suggest taking what we know and putting it in a table and kind of filling in the blanks of what we don't know. So I'm going to copy 0, 1, 2, 3, 4, 5. Okay, we know what's happening at 0, it's 5. We don't know 1, we don't know 2, we do know 3. 3 is 17, and we do know 5, that's 25. Now what we have going here is we have basically 1, 2, 3 steps in our table, and all we know is how those 3 steps are combined. The difference between 5 and 17 is a positive 12. So what you have to ask yourself is, can I take that big jump of 12 and divide it into 3 individual steps? In this case, it is pretty easy. 12 divided by 3 is 4. So what we're going to try is we're going to try and add 4 each time through this table to see if that, in fact, is our consistent rate. So I'll add 4, that gives me 9, gives me 13. 13 plus 4 is 17. I'll add another 4, that gives me 21. 21 plus 4 is 25. Now, this isn't definitive proof, but it is pretty good indication that we have ourselves a linear function. So let's start writing out this equation to see if it actually works for the couple points over here that we haven't gotten our table to yet. I think that we can say with at least some certainty that if this were linear, the rate of change would be 4. So I'm going to go ahead and put y equals 4x. We need 2 parts to our equation, our rate plus our y-intercept, or our starting point. That always happens when x equals 0. So my equation would be 4x plus 5. Now, let's check our 2 other points over here to see if they work out. If I put in a 10 for x, okay, 4 times 10 is 40. 40 plus 5 is 45. So if I put in a 10, I get out a 45. Is that what my table says? Yes. Put in a 10, got out a 45. Let's check the 12. 4 times 12 is 48. 48 plus 5 is 53. Sure enough, when I have a 12, I have a 53. So by filling in these gaps, you know, our new 1 value, our new 2 value, our new 4 value, we are able to see that despite this not looking very linear, it actually is a linear function, one in which we can write a rule for.